Hey, 2010 B, number 6 series. So let's see, we got the series for the function f is given by this on its interval of convergence. In part A, they want us to find the interval of convergence and then justify our answer. Notice that there's only a part A and B, so we better be careful to do everything we're supposed to do here. Find the interval of convergence, so that's the ratio test. So I want to find the limit as n approaches infinity of the n plus 1 term. Now remember, please remember, we don't care about the sign alternating, we only want positive values in this. So that would be 2x to the n plus 1 over n minus 1, n plus 1 minus 1, that'd be n, right? Divided by the n term, which means multiplied by that reciprocal. Right? And let's see, the x's come to the outside, and I've got one more of those, so the x's can come to the outside because they don't have anything to do with n going to infinity. And then that gives me the limit n minus 1 over n, and that's equal to 2x, right, because this limit is 1. And I need this to be in between -1 and 1. So the interval of convergence is -1/2 to 1/2, right? And now I'm going to check the endpoints. Check x equals -1/2. If I plug -1/2 in here, I have -1 to the n times -1 to the n. Those two -1 to the n's will cancel each other out. So that means all the terms will be positive, right? That's all just going to turn into a positive 1 up at the top. And then if I start plugging in numbers at 2, that gives me 1 over 1 plus 1 over 2 plus 1 over 3, which that's the harmonic series which diverges. So no equal sign there. And then we're going to check x equals 1/2. When I plug 1/2 in here, that just turns into a 1, and this alternates. So it looks like I'm going to get the alternating harmonic series. Starting with 2, the first term will be positive, -1/2 plus 1/3, and that converges. Because the terms go to 0 and it's alternating. So converge there, not there. Okay, I bet that was worth a lot of points. B, show that y equals f of x is a solution, in other words this, is a solution to the differential equation x times the derivative of y minus y equals 4x squared over 1 plus 2x for all the x's in the radius of convergence. Alright, well, let's see. I think I better write out a few terms of this to be able to see. So y would be equal to, when I plug 2 in here, I get, let's see, that would make this positive. It's going to alternate starting with a positive term. It would be 2x to the 2 over 1. Then the next term would be 2x cubed over 2 plus 2x to the 4th over 3, and so on. Right? Alternating. The derivative of that, maybe I'll just write out one more term so I have that. Okay, so the derivative, term by term, the derivative of 2x squared, the derivative of anything squared, that would be 2 times 2x to the first times the derivative of what's inside, which is 2. You could also square it and just get that way. And then here, I'd have 3 halves, that's bringing the exponent down, times 2x squared times the derivative of what's inside, plus 4/3 2x cubed times the derivative of what's inside, minus 5/4 2x to the fourth times the derivative of what's inside, and so on. Right, and maybe I should simplify that. So y prime is equal to, that would be 8x minus, or maybe I shouldn't simplify it. Maybe I should leave the 2x's in parentheses. How about that? See, so it can match up to other stuff. So let's write that as 4 times 2x. Let's write this as 3 times 2x squared plus 8/3 times 2x cubed minus 5 halves 2x to the fourth, and so on. Oops, there it is. And they want us to show that x times y prime minus y is equal to this. And let's see if we can do that. So x times y prime would be equal to, maybe I do have to simplify these terms. I really don't want to. All right. Well, I got to distribute an x through this, right? So I guess I have to. So that's going to be 8x squared minus 2 squared is 4. That's minus 12x cubed. Then plus 2 cubed is 8. That's 64 over 3 x to the fourth minus 16 times, or 8 is 40 x to the fifth. And I guess I could simplify this too. Y equals, the first 4 terms simplified, 4 squared would be 4x squared minus 8 cubed divided by 2 is 4x cubed plus 2 to the fourth is 16/3 x to the fourth minus 32 divided by 4 is 8x to the fifth, and so on. Okay, now let's put them together. So they want us to do x to do this minus this. Okay, so this minus this, that's 4x squared. This minus this, that would give me minus 8x cubed. And then those are both in thirds. So this minus this would be 48. No. Yes? 48 over 3 is 16, isn't it? So I think that's going to give me plus 16x to the fourth. And then minus 40, so then be minus 32x to the fifth, and so on. Right? That's x times y prime minus y. Now listen, I'm doing the same thing that you would do here. I don't know where this is going. I'm just doing what they said, right? I just took the series that I had, and I'm just manipulating it, and I'm subtracting it, and I'm hoping that somehow I can get to this. But now I can see that this is a geometric series. Right? What's the first term? That. What's the multiplier? That's your A. Your first term, and the multiplier, it looks like it's negative 2x. Right? So the sum would be equal to the first term, 4x squared, over 1 minus the multiplier, and that's what we were shooting for. So listen, that's pretty nuts, but you just need to, if you run into some crazy thing like solution to this differential equation, you just have to try to make this and see what happens and hope for the best. So there you go.